Hi everyone, this is the first problem from PA10 2.16, and in this particular problem we need to determine all currents and node voltages in this circuit. So we have an inverting amplifier here using an op amp, and the voltage that we have, so basically we have the grounds, right? So at those nodes here we know that we have 0 volts, right? So here is 0 volts, here is 0 volts, here is 0 volts, and we still need to define voltages here and here, right? Those are the nodes that we don't know the voltages. And we also have current, so we have this current here, right? We have this current here, we have a current here, a current here, a current here, and another one here, right? So those are the currents that we need to define. So first thing is that we should consider this op amp as ideal. So for an op amp ideal, we know that the voltage at the non-inverting input is equals to the voltage at the inverting input. Now if we look at the circuit, we know that this V plus here is equals to 0, right? Because it's grounded. So this is 0 volts, which implies that V minus is also 0 volts. So this particular node here, we know that is the voltage, the potential there is 0 volts. Okay. Another thing is that for the ideal op amp, we know that I minus is equals to I plus is equals to 0 amperes. So this current here and this current here, they are 0, so there's no current flowing inside or outside of the inverting and non-inverting inputs because of the infinite input resistance, right? So remember that this assumption here comes from the open loop gain equals to infinite, and this one here comes from the assumption that the input impedance, okay, or resistance is also infinite, so there's no current flowing inside of the op amp. Okay, so we have defined those two currents and those two potentials, right? Now we need to apply a nodal analysis and figure out the voltage transfer function. Okay, so if we start analyzing this node here, right, this, let me use red, so this node here, we know that V minus the potential at this terminal here, okay, which in our case is minus 1 volt because this voltage source forces that to be true. So minus 1 divided by that 1k plus V minus V out. So let me, this is V out, right? Minus V out divided by 10k should be equals to 0, right? Because this current here is 0. So we have only this current here and this one here. Now, if you remember, V minus is 0 here and there. And in this case, we can isolate V out. So V out is equals to minus 10k divided by 1k times minus 1, right? That's what we have. So let me just Yeah, because the voltage transfer function, so V out over Vi is equals to minus R2 over R1, right? So in our case we have Vi equals to minus 1, so this gives us minus 10 times minus 1, okay? Which gives us a V out equals to 10 volts. Okay, so now that we know V out, so we know V out here is 10 volts, right? We can calculate the currents. Okay, so we have a current flowing here. We'll call this I2K, and this I2K is equals to that 10 minus 0 volts potential here divided by 2K, which is equals to 5 milliamps. This current here, so we also have, so this is, remember, 0 volts, so we have a current flow in this direction here, and I'll call that I10K. This is I10K, which is equals to 10 minus 0 divided by 10K, and this is equals to 1 milliamp. In here we also have a current flowing in this direction. Remember, this is minus 1 volt, so this is I1K. And as you know, I10K should be equals to Y1K because we don't have any currents flowing inside here, the op amp. So I1K is equals to 0 minus 1 divided by 1K, and that's equals to 1 milliamp. So those two, they agree with each other in our assumption of ideal op amp. So we know the currents. Now we still need to define this current here, right? So this current here that I will call I out is the sum of I2K plus I10K, and that gives us 6 milliamps. Now the question is, where does this 6 milliamps come from, right? So we have 1 milliamp here, we have 1 milliamp here, we have 5 milliamps here. So this is coming from inside the op amp, but from where, right? So if you remember, the op amp, it doesn't have just these terminals that we have drawn here. So it has usually a minus VDD and a plus VDD. So in this case, this 6 milliamps are coming from this VDD here, right? So it's coming from the voltage source that we use to power the op amp. That is not drawn in the first circuit, but we have it connected to a real op amp. Okay.